All right, let's take a quick moment to just refresh. What is the power rule for derivatives? Remember, if you take the derivative of x to the n, we bring the exponent down, and then we take away 1 from the exponent. So if you think about it, we multiply by the exponent and then take away 1. This is the antiderivative now, so it's very, very similar. Instead of taking away 1 from the exponent, we're going to add to the exponent and then divide by whatever that exponent is to cancel out what we had done earlier by bringing down the exponent. So it's a reverse. It's the reverse of the power rule, which is why it's called the reverse power rule. I didn't really think about that. Just saw that right there, right now. So the idea, once again, is if we have to multiply in the derivative power rule, well, we're going to divide this time. If we had to subtract 1 from the exponent, we're going to add 1. And we can always double check our answer. So our antiderivative here is going to be t. We're going to put 4 plus 1 is 5, and then we're going to divide by that current exponent. Why would we divide by the current exponent? Well, if we wanted to take the derivative of this, it should go back to t to the 4th. So if you take the derivative, bring down the 5, take away 1, and then it's over 5 cancels out, leaves us with just t to the 4th, which is what we want. So that's why we're dividing by the exponent. What's the plus c? When we do an antiderivative, there can always be a constant of integration is what we call it. The reason why is, who knows? Maybe in this function, in this antiderivative function, there was originally 25 here. We don't know. But when we take the derivative of this function, it brings us to t to the 4th. And remember, the derivative constant is 0, so it goes away, and we'd be left at t to the 4th. So we don't know what this constant is. We just know that there could have been a constant there. So we're going to put this kind of placeholder of c that says, hey, there might be a constant here. We need to check it. And we're going to later on figure out how to solve for it using an initial value to figure out if there was a constant there before. So we do need additional information if we want to find out what that constant is. But for now, we're just going to put plus c to represent that, hey, there could be a missing constant there. Okay, let's try another one. This one becomes x to the 10, and then we divide by 10. This one, well, currently the exponent's a 1, right? So then that goes up to a 2 and divide by 2. X squared over 2. It makes sense. If you take the derivative of this, it returns back to x. Bring down the 2, those cancel out. The exponent becomes a 1. You're left with just x. And derivative constant is 0, so it goes